Hello everyone. So in this section, 2.4, this is the last section in chapter 2 on fractions, and I want to talk about multiplying and dividing fractions. So again, let me motivate this by looking at an example of multiplying two fractions using diagrams, using pictures. Let's say I want to multiply 1/3 times 2/5. So 1/3 times, usually we represent multiplication by a dot. So a dot and then 2/5. So I can represent, let me do 2/5 first. I can represent 2/5 as a rectangle. And if I divide it into 5 pieces, right, 5 equal pieces, equal areas. And then if I shade 2 of those pieces, that's going to be 2/5. Okay, so this represents 2 out of 5, right? 2/5. And then 1/3, I'm going to do this where I'm going to draw the same size rectangle, or at least do the best I can. Split this up into 3 pieces. And if I shade one of them, let's just shade the left one, this represents 1/3. So if I want to multiply 1/3 times 2/5, first of all, you can think of multiplication as meaning of. So this really means the same thing as 1/3 of 2/5. Okay, so if I want 1/3 of 2/5, again, the left picture represents 2/5, right? So if I want 1/3 of it, I can like superpose these pictures. I can put one picture right on top of the other. So let me draw that here. So again, right, this is the shaded part, the 2/5. And then 1/3 of it, I'm going to put the other rectangle right on top of this. So it'll look something like this. Where this is the shaded piece again. And the answer, 1/3 of 2/5, is going to be where it's shaded twice. And you can see that right here, right? This is where it satisfies both, right? It's shaded twice here. So what part is shaded twice? Well, if you notice here, now I have 15 little areas that are equal, right? 15 little rectangles, and 2 are shaded. So this is what it's saying is that 1/3 of, or times 2/5, is equal to 2/15. Right? So 2 rectangles out of a total of 15 end up being shaded. Okay, so that's it in pictures. Let's learn how to do it algebraically now, or at least using arithmetic. So here's the rules. So to multiply fractions, you multiply the numerators multiply the denominators, and then simplify. And then I also want to mention that often we will simplify first by canceling any common factors and then multiply. You can do it either way. You could simplify at the end, but often it's quicker and easier if you simplify first. So let me just write that as a 4th point. So often we will simplify first, meaning cancel any common factors. Then multiply. So then you multiply numerators and denominators. You can really do it either way. You're going to find it's going to be quicker to simplify first. Okay, so for example, let's say I want to multiply 7/8 times 1/2. So I try to simplify first. There's nothing I can cancel, right? 2 doesn't go into 7. 7 doesn't go in. There's nothing that goes into 7 and 8. So there's nothing I can simplify. So I'm simply going to multiply numerator. So 7 times 1 is 7. And then denominators, right? 8 times 2, that's going to be 16. So 7/8 times 1/2 is 7/16. Okay, what about 4/5 times 1/4? So you could just multiply numerators, right? So if I multiply 4 times 1, that'll be 4. And then the denominator is 5 times 4, that's going to be 20. And then notice you can simplify this, right? 4 goes into 4 once, 4 goes into 25 times, so this simplifies to 1/5. Another way you could have done this was simplify first. And I think ultimately you're going to find that it's better and quicker to simplify first. So notice here, right, since I have a 4 in numerator, 4 in denominator, I can simplify. 4 goes into 4 once, 4 goes into 4 once. So now I multiply numerators. 1 times 1 is 1, 5 times 1 is 5. And you get the same thing, but it's typically quicker. What if we square something? Remember when we talked a little bit about exponents and powers? This means, right, 1/8 squared means 1/8 times 1/8. So again, I can't simplify, so I multiply numerators. 1 times 1 is 1, and then 8 times 8 is 64. And that would be my answer. So 1/8 squared is 1/64. How about 5/2 times 9/8? Let's see, can I simplify? Well, 2 doesn't go into 9, 2 doesn't go into 5. Doesn't look like I can simplify in this case, right? So I multiply numerators. 5 times 9 is 45. And then 2 times 8 is 16. And of course, now this is an improper fraction, right? So that's fine. You could leave it like that, or you could also write it as a mixed number. And remember, to write it as a mixed number, you'd have to divide. So 45 divided by 16. 16 goes into 45 twice, right? So this would be 32. Then I would subtract, and that's my remainder. So, or I could also write this as 2, and then I take the remainder, 13 over 16. So it's either 45/16 or 2 and 13/16. Sometimes you'll see numbers written with parentheses next to one another. That also means multiplication. So those two numbers in parentheses right next to another means multiply them. In this case, we can simplify, right? See how 3 goes into 3 once, and 3 goes into 6 twice. I can put a 2 there. And then 4 goes into 4 once, 4 goes into 8 twice. So this is simply going to be, in the numerator, I just have 1 times 1, right? That's all that's left over, so that's 1. And in denominator, 2 times 2 is 4. So 4/6 times 3/8 is really 1/4. And then if you have a whole number times a fraction, right? Let's say I want to do multiply 20 times 5/4. You can easily write the whole number as a fraction, right? Remember, you can always put it over 1. So that turns it into a fraction, and it still means the same thing. So what's 20 over 1 times 4 over 5? Well, I can simplify first, right? 5 goes into 5 once. 5 goes into 20 4 times. So I have 4 times 4 is 16. In the denominator, I have 1 times 1 is 1. So, of course, anything over 1 is itself. So this is just 16, right? The answer just turns out to be a whole number in this case. Okay, so that's if you just have regular fractions. What if you want to multiply mixed numbers together? So let's look at the rules for that. So to multiply mixed numbers. Okay, here's what you do. You first convert them to improper fractions. So I'll say write the mixed numbers as improper fractions. Then you multiply the fractions. And then for the answer, you convert back to a mixed number. So multiply fractions. And then convert back. Because usually if they give you the original question in terms of mixed numbers, they will want the answer in mixed numbers. And my open math will tend to be like that too. It'll usually tell you whether you can put it in mixed number or just leave it as improper fraction. So usually we convert back to a mixed number. And then simplify, of course, if possible. Okay, so for example, okay, so let's look at some examples here. Let's say I want to multiply 5 1/4 times 1 1/9. Okay, so first, convert them to improper fractions. So remember, I multiply the denominator by the whole number part, so 4 times 5. I add the numerator and put it over the denominator of the fraction. So this will be what? 20 plus 1 over 4. So this is 21/4 times, and then for the 1 1/9, that's going to be 9 times 1 plus 1 over 9, right? So 9 plus 1 is 10. So this is 10/9. Okay, so now I multiply these two improper fractions together. Well, I can first simplify, right? If you look at 4 and 10, it looks like 2 will go into these, right? So 2 goes into the 4 twice, 2 goes into 10 5 times, and it looks like 3 will go into 9 3 times, and 3 will go into 21 7 times. So then if I multiply numerators, 7 times 5 is 35, and denominators 2 times 3 is 6. And that's my answer. However, because the original problem was in mixed numbers, I probably want to convert that to a mixed number. So I will do that by dividing. Let me do it over here. So let's see. 6 goes into 35, I guess, 5 times, right? 5 times 6 is 30. I subtract. My remainder is 5. So this is going to be 5 5/6. So my answer is a mixed number, but really I converted everything to fractions first, worked with the fractions, and then converted back to a mixed number. Okay, here's another example. Let's say I have 1 1/4 squared, and then I want to multiply that by 1/5. Okay, so first of all, what's 1 1/4 as a mixed number? Sorry, it is a mixed number. What is it as an improper fraction? Well, remember, it's going to be 4 times 1 plus 1 over 4, right? So that's going to be 5/4. So this is really the same as 5/4 squared times 1/5. So if I write this out, remember 5/4 squared means 5/4 times 5/4 times 1/5. So I could cancel one of the 5's, right? Doesn't matter which one, say that one. And now you multiply numerator, so 5 times 1 times 1 is 5. And then 4 times 4 times 1 is 16. And that actually is a proper fraction, so that's it. That is our answer. So 5/16. Okay, so all you have to do with mixed numbers is convert them to improper fractions first, multiply them as fractions, which we already know how to do, and then at the end, if need be, convert back to a mixed number. In this case, we ended up with a proper fraction. We didn't even have to convert back. All right, so that's multiplying fractions. What about now divide? Let's talk about dividing fractions. So dividing fractions. Okay, so before we even get into how to divide fractions, I have to mention one concept that we need. It's the idea of a reciprocal. And to find the reciprocal of a fraction, all you have to do is flip the fraction. Or, if you want to say it better, we basically interchanging the numerator and denominator. So I'll say interchange the numerator and denominator. Okay, you can think of it as flipping the fraction. Right, we will need that concept. So actually here, let's do a couple of examples with that. Let's say this is the original number, right, the original fraction, and I want to find its reciprocal. So if the original number was 2/5, what is the reciprocal? Well, the numerator becomes the denominator becomes the numerator. I flip it, so it's going to be 5/2. If the original number were 9/8, what's the reciprocal? Well, I flip it. So the 8 is going to become the numerator, the 9 is going to go down and become the denominator. If the original number were 5, what is the reciprocal? Well, you have to remember 5 can be written as 5/1. So the reciprocal is going to be 1/5. And notice here, in all these cases, right, if I multiply the original number, I'll just do it for the first one, times the reciprocal, what do I always get? I'm always going to get 1, right? See how the 2's cancel, 5's cancel. I'm going to get 1/1, which is 1. And that's always true. Any number times its reciprocal will give you back 1. All right, so now that we have the idea of reciprocal, we can divide fractions. So let me give you the rules for that. So to divide fractions, what you do is you change the divisor, right, the number being the fraction being divided, to its reciprocal, then multiply the resulting fractions. So change the divisor to its reciprocal, then multiply the resulting fractions. And of course, always simplify if necessary. So step 2 will be simplify. Okay, so basically what you're doing is you're changing a division problem into a multiplication problem. So here's an example. Let's say I want to divide 2/3, right, divided by 3/5. Okay. By the way, I could also write it like this, right? I could say this is 2/3 over, which means divided by 3/5. Okay. Either way, what you do is the first fraction stays the same, so it stays as 2/3. Right? It's called the dividend. And the second fraction, the divisor, you have to flip it. So instead of 3/5, it becomes 5/3. And now you multiply. So you multiply by the reciprocal of the divisor, right? You flip the second fraction. Now, can we simplify first here? No, it doesn't look like it, right? 3 doesn't go into any of the numbers in the numerator. So I just multiply across, right? So 2 times 5 is 10. 3 times 3 is 9. So this is going to be equal to 10/9. Or if you want to write that as a mixed number, it's going to be 1 and 1/9. Okay, here's another example. Let's say I have 1/7 divided by 1/2. Well, remember, that's going to be 1/7. The first fraction stays the same, right? And then you multiply, and I flip the second fraction. So it becomes times 2 over 1. So now I multiply numerators. 1 times 2 is 2. Denominator, 7 times 1 is 7. And that's my answer. So 1/7 divided by 1/2 is 2/7. Okay, what if I have a whole number, like 10 divided by, say, 5/2? Again, we can think of 10 as 10 over 1. Right? So I have really 10 over 1 divided by 5/2. So the 10 over 1 stays. The division becomes a multiplication, and I flip the second fraction. It now becomes 2/5. Then we should simplify first, right? So it looks like 5 goes into 5 once, and it goes to 10 2 times. So now if I multiply numerators, 2 times 2 is 4, and denominators, 1 times 1 is 1, so this is simply equal to 4. So 10 divided by 5/2 is really just equal to 4. Okay, what about dividing mixed numbers? So how do you think we're going to divide mixed numbers? And you might guess this, right? Basically, we kind of do the same thing that we did when we multiplied mixed numbers. We convert them into improper fractions first, and then we divide those improper fractions and then convert back to a mixed number for the final answer. So I'll just write to divide mixed numbers convert them to improper fractions first. Okay, so for example, let's say I'm given 3 1/7 divided by 2 1/2. Okay, so convert the first mixed number into an improper fraction. Well, it's 7 times 3, right? 21 plus 1 is 22 over 7, and then divided by, and the second mixed number as an improper fraction would be 2 times 2 is 4 plus 1 is 5 over 2. So to divide them now, remember the first fraction stays the same, and I multiply by the reciprocal. I have to flip the second one. So in this case, it doesn't look like it can simplify much, right? So I'm just going to multiply across the tops. 22 times 2 is 44. And then the denominators. 7 times 5 is 35. And then we probably want this back as a mixed number. So the last step is just convert this back. So I will divide it to convert it back to a mixed number. 35 goes into 44 once. And looks like the remainder is going to be, what, 9? So this is also equal to 1 and 9/35. Okay, so this problem was really equal to 1 and 9/35. All right, another example. Let's say I have 15 and 2/3 divided by 5/6. Okay, so the second fraction is already a proper fraction, right? I don't have to convert it or anything. So just convert the first mixed number into an improper fraction. So 3 times 15 is 45, plus 2 is 47 thirds divided by 5/6. Well, that's the same as 47 thirds, so 47 over 3, times, and I have to flip it, right? So 6 over 5. I can simplify a little bit here, right? 3 goes into 3 once, 3 goes into 6 2 times. That's about all I can do. So now I multiply the numerators. 47 times 2 is going to be 94. And then the denominator, 1 times 5 is 5. And then I'll convert back. I'll divide 94 divided by 5. Oops, by 5. So let's see. 5 goes into 9 once. I subtract, right? I'm going to get 4. Bring down the next digit, 4. 5 goes into 44, I guess 8 times. So that'll give me 40. Subtract, I get 4. So this is going to be 18 and 4/5. Right? So that's my answer. So 15 and 2/3 divided by 5/6 is equal to 18 and 4/5. Okay, let's do a couple of more examples that are a little harder, where we have to use order of operations. Okay, so here's another example. Let's say I have 1/2 plus, we'll have to use everything we learned in the last section as well, plus 2/3 times 1 1/3. Okay, so I have addition, I have multiplication. Remember from order of operations, right? Please excuse my dear Aunt Sally, or PEMDAS. Multiplication has to be done first. So I have to do this, I'll just do it on the side here. I have to do 2/3 times 1 1/3 first. Well, how do I do this? Well, I need to convert that mixed number into an improper fraction. So this will be 2/3 times, what's that going to be? 3 times 1 plus 1 is 4 over 3. Now I can multiply them together, right? I can't simplify first, so 2 times 4 is 8, and then 3 times 3 is 9. So this problem now becomes 1/2 plus, and in this piece we just found was 8/9, right? This is 8/9. Okay, now I need to add them. Well, adding fractions, right, is a little more complicated because we have to have the same denominator. So we want to find the lowest common denominator of 2 and 9. Well, in this case, it's just going to be the product of the two, right? 18 is the smallest number that 2 and 9 will go into evenly. So I can correct this by multiplying by 9 over 9. And then this one I can correct by multiplying by 2 over 2. So I'm going to get 9/18 plus 16/18. And then if I add that together, right, now I add the numerator, so 9 plus 16 is 25, and I keep the denominator, 18. Or if you wanted it in mixed number, if you divide that, you're going to find it's 1 and 7/18. Okay, so this whole thing is really equal to 1 and 7/18. All right, here's another one. where again we have to use multiple steps because we have to be careful of our order of operations. So 1 minus 2/5 squared divided by 1.5 squared. Okay, so what do we need to do first? Well, we need to do parentheses, right? Inside parentheses. So in this case, right, in the left parentheses, I guess they're at the same level in this case, right? The left parentheses, I can definitely do that subtraction. There's not much I can do in the right parentheses, although I could write it as an improper fraction. I should do that. So let me do the left parentheses first. I need to do 1 minus 2/5. Think of 1 as 1 over 1. Well, in order to subtract, I need to have the same denominator, right? So the lowest common denominator obviously is 5 in this case. So I can multiply by 5 over 5. So this is really 5/5 minus 2/5, which is 3/5. And then the 1 and 1/2, if I convert that to an improper fraction, right, it's 2 times 1 plus 1 over 2. So that's going to be 3/2. So now this problem becomes 3/5 squared, right, divided by 3/2. Oops, wrote that down wrong here. Divided by 3/2 squared. Right, so 3/5 squared divided by 3/2 squared. Okay, but what does it mean to square the numbers? Well, I'll do it on the side over here. Remember, 3/5 squared means 3/5 times 3/5. So that's going to be 9/25. And then 3/2 squared means 3/2 times 3/2. So I multiply numerators, 9 over 4, right? So now I have 9/25 divided by 9/4. Well, how do I divide these two fractions? Well, I keep the first one, right? It stays the same. And I multiply by the reciprocal of the second, of the divisor. Notice here I can cancel the 9s, right? 9 over 9 is 1. Or 9 goes into 9 once, 9 goes into 9 once. And I'm left with 4/25. So that was my answer. So this whole thing turned out to be just 4/25. Okay, let's finish up this section by doing a couple of problems from my open math. So in this problem, it says identify the fractions labeled with the letters A and B on the scale below. Give your answers as proper or improper fractions. Okay, so notice here, right, we have 0, 1, right? Those are given. And notice how many intervals I have between 0 and 1. I have 1, 2, 3, 4, 5, 6, 7, let's say, 7, 8, right? I have 8 intervals. 1, 2, 3, 4, 5, 6, 7, 8. So the A is at the first, within the first interval. So that means the A must represent 1 over 8, right? It's 1 out of 8. So that's the A. It represents the fraction 1/8. Now the B, so again, I have 8 intervals here, right? So if I keep going, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the B is like 14 over 8, right, out of 8. But then that can be simplified. Two definitely goes into both of them, right? So this will be 7 out of 4. So B represents the fraction 7/4, right? And it makes sense. Or if you want, write it in as a mixed number. So if I divide that, right? If I divide 7 divided by 4, this is 1, remainder is 3. This is going to be 1 and 3/4. And again, that makes sense, right? It's 1, and then it's 6 over, right? It's 6 out of 8, so that's 3/4. Okay, so you could get some questions like that where they give you a number line and you have to figure out what each letter represents in terms of the fraction, what fraction it identifies. Okay, what about this question? If elephant grass grows 2¼ inches a day, how many inches will it grow in 9 days? Okay, so basically I'm given like a rate, right? Go back to my pencil here. 2¼ inches per day. And I want to know how many inches it'll grow in 9 days, so I have to multiply by 9 days. Right? And then again, days will cancel, and I'll end up with an answer in inches, right? That'll give me how many inches it's grown. So really it's multiplying, but it involves a mixed number times a whole number. Okay, so how do we multiply those two numbers together? Well, let's do it over here. So I have 2¼ times 9. So remember, convert both of them to fractions, right? To convert the mixed number into an improper fraction, I multiply 4 times 2, 8, add 1. It's going to be 9/4. To convert the whole number to a fraction, I simply put it over 1. So this is going to equal, I can't simplify it, right? So multiply numerators, 9 times 9 is 81. Denominators, 4 times 1 is 4. And then since they gave a mixed number in the answer, they may want the answer as a mixed number. Probably this would be fine if you put 81 over 4. But let me write it also as a mixed number. So 4 goes into 8 twice. Right, 2 times 4 is 8. I subtract that 0, bring down to 1. 4 goes into 1 0 times. Right, so 0 times 4 is 0. Subtract, have 1. So this is going to be the same as 20 1/4. Okay, so it looks like it's going to grow 20 1/4 inches if it grows for 9 days at a rate of 2 1/4 inches per day. And that makes sense, right? It's going to be much larger. If we would estimate this, right, we would say that's about 2. 2 times 9 is about 18. Yeah, we're getting, and we know it's a little bit more than 2. We're getting a little more than 20. So that seems very reasonable for an answer. Okay, and then let's do one last question here. So this question says, each dose of aspirin weighs 3/4 grain. If a hospital pharmacist has 9 grains of aspirin on hand, how many doses can he provide? Okay. So again, if you think about this, right, this is really going to be nothing more than a division problem. I need to take the total number of grains, which is 9, and divide that by 3/4. And that's got to be how many doses, right? In fact, if we think about this, we can do this in terms of units as well. So think of it as 9 grains divided by, you can even think of it as 9 over 1, divided by 3/4. This really means grain per dose. So if I want to divide those, right, then remember the first fraction stays the same, as well as the units. So this will be 9 over 1 grains times, and I have to flip the second fraction, right, the divisor, as well as flipping the units. So this is 4, you can think of it as doses over 3 grains. Right, the units also flip. And notice here now, to multiply these, first of all, I can simplify, right? 3 goes into 3 once, 3 goes into 9 3 times. I can cancel the units of grains, right, to cancel out, and I end up with what I want, which is the number of doses, right, the units of doses. So 3 times 4 is 12, 1 times 1 is 1, so this is going to be 12, and it has units of doses. So 12 doses. But really it was nothing more than a division problem. We just had to divide 9 divided by 3/4. Okay, and you may have seen that intuitively. It also works out if we look at the units. All right, that's it for this section. And next time we will move on to decimals, the next module. Great, thanks.